There is a moment in every story of the universe where language begins to fail. Not because we lack words, but because the thing we are trying to describe exists beyond the rules that make words meaningful in the first place. Picture this: absolute darkness. Not the darkness of a closed room or a moonless night, but something deeper. A darkness with no direction, no distance, no time to measure it against. No before, no after. And then, without warning, everything begins. Space itself expands, not into anything, but into existence. This is the Big Bang. But here is the unsettling part that modern physics cannot easily escape. If time, space, and matter all began here, then what exactly came before? It is a question that sounds simple, almost childish, yet it has become one of the most profound scientific mysteries ever posed. Because when we trace the universe backward, galaxies unwinding, stars collapsing into silence, atoms breaking apart into raw energy, we eventually arrive at a boundary, a point where our equations stop working, a place where reality becomes undefined. Physicists call it a singularity. But singularity is not an answer. It is a warning sign. It tells us our understanding has reached its limit. And yet, the universe did not start as an explosion in space. It was not a bomb going off in empty darkness. Space itself was smaller, denser, hotter, compressed into a state so extreme that all known physics collapses. Even the concept of outside may not have existed. So when we ask what came before the Big Bang, we may already be making a mistake. We may be assuming that time is like a river flowing endlessly backward, when in reality, time itself might have been born at that very moment. But not everyone agrees. Some theories suggest something else entirely, that our universe is not the beginning, but a transition, a phase in something far larger, older, and far more strange than we can currently comprehend. A cosmic cycle, a bounce, a collision, a fluctuation in a deeper fabric of reality we have not yet learned to see. And if that is true, then the Big Bang was not the beginning of everything. It was simply the moment we became aware that something came before it. Because somewhere, hidden beyond the observable edge of space, there may be a history we cannot access. A prelude written in physics we do not yet understand. A universe before the universe. And the deeper we look, the more unsettling it becomes. Because every answer we find seems to whisper the same thing. We are only seeing the beginning of the story. To understand what before might mean, we have to abandon the idea that time is obvious. In everyday life, time feels absolute, a straight line, past, present, future, clean and ordered. But modern physics has already broken that intuition. According to Einstein's theory of relativity, time is not separate from space. It is woven into it, forming a four-dimensional structure, space-time. And this structure is not fixed. It bends, it stretches, it slows down near massive objects like black holes, which means something extraordinary. Time is not universal. It is local. So when we rewind the universe to its earliest moments, we are not simply reversing a film. We are moving through a physical structure that may not even support the concept of earlier beyond a certain point. At approximately 10 to the power of minus 43 seconds after the Big Bang, the Planck time, our current laws of physics stop making reliable predictions. Gravity, quantum mechanics, and space-time itself become inseparable in a way we cannot yet describe. This is not just a technical limitation, it is a wall. Beyond this wall, we cannot say what happened with certainty. We can only speculate, and speculation, in cosmology, is where things become both exciting and deeply unsettling. One idea suggests that the Big Bang was not a singular beginning, but a transition from a previous state of the universe, something like a cosmic rebound. In this scenario, the universe may have once been contracting, collapsing under its own gravity, shrinking down toward an extremely dense state. But instead of ending in a true singularity, quantum effects could have caused a bounce, reversing the collapse into expansion, a big bounce instead of a big bang. This idea appears in several approaches to quantum gravity, where space-time is not continuous, but made of discrete fundamental building blocks. At extremely small scales, these structures might resist infinite compression, preventing the formation of a true singularity. If that is true, then our expanding universe could be the aftermath of a previous cosmos that existed before ours, one that collapsed, rebounded, and restarted the cycle. But there is another possibility, one even more difficult to visualize. The idea that our universe is not unique, that it is one bubble in a vast cosmic foam. In this view, space itself is constantly inflating at an enormous scale, producing countless universes, each with its own physical laws, constants, and history. Our Big Bang would then be local, like a bubble forming in boiling water. From the outside, if outside even has meaning here, there is no single beginning, only endless creation. And somewhere in that infinite process, our universe emerged. But none of these ideas are confirmed. They are mathematical possibilities, attempts to push theory beyond its known limits. Still, they share one haunting implication. The Big Bang may not be the beginning of everything. It may simply be the beginning of our everything. And that distinction changes everything. Because if something existed before, even in a form we cannot yet describe, then the universe is not a story that starts at zero. It is a continuation, a chapter in something far older than time itself. There is another idea, stranger than most and yet taken seriously by some of the most respected minds in theoretical physics. It begins with a question that sounds almost philosophical, but is deeply mathematical. What if the universe did not begin at all? What if beginning is not a real feature of reality, but an illusion created by the way we observe it? In this view, time itself might not be fundamental. Instead, it could be emergent, something that arises from deeper, more abstract laws where time does not exist in the way we experience it. One of the most intriguing attempts to describe this comes from the no-boundary proposal. In this model, the universe does not start from a sharp point in time. There is no initial singular edge where everything breaks down. Instead, the earliest state of the universe is more like a smooth geometric transition, where time behaves more like a spatial dimension. In simple terms, there is no before the Big Bang, because the concept of before loses meaning. It is like asking what is north of the North Pole. The question assumes a direction that does not exist beyond a certain boundary. But even this idea does not close the door on something prior. It only reshapes it. Because other theories suggest the universe is not a singular event, but part of a repeating structure. In cyclic cosmology, the universe undergoes endless phases of expansion and contraction. It grows, spreads, cools, and eventually gravity begins to pull everything back together. Galaxies slow their drift, stars burn out, and space itself begins to collapse inward. Then, at some extreme limit, a new expansion begins. A new Big Bang, a new cycle. No true beginning, no final end, only transformation. And then there's a more exotic idea still, one born from string theory and higher dimensional physics. In this scenario, our universe exists on a three-dimensional brane. floating in a higher dimensional space. Another brain, parallel to ours, could exist just out of reach, except for gravity, which might leak between them. Some versions of this model suggest that the Big Bang was caused by a collision between these cosmic membranes. A violent encounter in a higher dimension, releasing unimaginable energy into our universe. If true, then what we call the Big Bang was not the creation of everything, but the result of something happening elsewhere. A cosmic impact beyond our perception. But perhaps the most unsettling idea is not that something came before the Big Bang. It is that our concept of before may itself be incomplete. Because all of these theories, bounce, cycle, multiverse, brains, still rely on the idea that cause precedes effect. Yet at the edge of the Planck scale, causality itself becomes uncertain. Quantum fluctuations do not behave like classical events. They do not follow a neat sequence. Instead, they exist in probabilities, where outcomes are not determined until they are observed. So what if the universe itself began as a fluctuation? Not an explosion, not a collision, but a quantum event without a clear origin. A spontaneous emergence from a deeper vacuum state that is not truly empty, but filled with potential. And if that is true, then the Big Bang was not the first moment of existence. It was the moment possibility became reality. To go further back than the Big Bang, we must confront something deeply uncomfortable. Our universe may not be self-contained. For centuries, cosmology assumed that everything that exists is contained within the observable universe: space, time, matter, energy. Even the most radical models still tried to describe reality as a complete system. But modern theoretical physics keeps pointing towards something larger, something underlying, a structure that does not behave like space in any familiar sense. Some physicists call it the quantum vacuum, but that term is misleading because vacuum suggests emptiness, and there is nothing empty about it. At the smallest scales, we can theorize space-time may be turbulent, fluctuating, foaming with virtual particles, appearing and disappearing faster than we can measure them, while an empty space contains energy. And that energy is not static. It is dynamic, restless, and unstable. Now imagine scaling that idea up, far beyond particles and fields. Imagine that our universe is not the whole system, but a local disturbance in a deeper quantum reality. In this view, the Big Bang was not the creation of space and time. It was a phase change, like water freezing into ice or boiling into steam. The fundamental structure of reality may shift between states. What we experience as expansion could be the result of a deeper field settling into a new configuration. And if that is true, then before the Big Bang does not refer to a time period. It refers to a different state of existence, a phase where the rules of physics, as we know them, did not apply. But there is another direction this idea takes, one that pushes even further into abstraction. Some versions of quantum cosmology suggest that universes can form spontaneously, much like particles in a quantum field. In a vast multiversal landscape, each universe is like a bubble nucleating from a deeper meta-reality. Most of these bubbles would be short-lived, collapsing before anything complex could form. Others might expand, cool, and evolve, becoming stable universes like ours. If this is true, then the Big Bang is not unique. It is routine, a natural process in a much larger cosmic system. And somewhere in that system, there could be countless universes, some younger than ours, some older, some with entirely different laws of physics where stars never form, or time flows backward, or dimensions behave in ways we cannot even imagine. But even this raises a difficult question. If universes can form from a deeper reality, what is that deeper reality? What is the ground state from which everything emerges? We are forced to confront a possibility that is both elegant and unsettling, that there is no final layer, no ultimate foundation, only deeper and deeper descriptions, each revealing a new level of structure, like peeling an infinite onion. And at some point, our intuition breaks completely, because we are trying to apply human concepts, time, cause, sequence, to a system that may not use them at all. Which brings us back to the original question. What came before the Big Bang? Perhaps nothing, or perhaps something so fundamentally different that before is the wrong word entirely. Because in the deepest sense, the Big Bang may not be the start of existence. It may be the moment existence became observable, the moment the universe began to have a history. If the universe truly has a deeper origin, it may not reveal itself in the way we expect, not through dramatic explosions or visible boundaries, but through subtle traces hidden in the structure of space-time itself. Cosmologists search for these traces in the cosmic microwave background, the faint afterglow of the early universe, stretched across billions of years of expansion. It is the oldest light we can observe, a fossilized snapshot of a time when the universe was still hot, dense, and young. And yet, even this ancient light is not the beginning. It is already a record of a universe that had been evolving for hundreds of thousands of years. So the question becomes, what lies beyond even this horizon of observation? Some theories suggest that the imprint of a pre-Big Bang state could still be encoded in subtle irregularities, patterns in temperature fluctuations, anomalies in large-scale structure, or unexpected correlations in cosmic radiation.
Wait, look at this.
If the universe
It's not
experienced
natural.
a bounce
It's
or
pulsating.
emerged from a prior phase, those events might have left behind faint scars in the cosmic fabric. But so far, nothing definitive has been found, and that silence is important, because absence of evidence does not necessarily mean absence of cause. It may simply mean that the signal is too deeply buried, or that our instruments are not yet sensitive enough to decode it. Or perhaps the transition into our universe was so extreme that it erased almost all traces of what came before. There is also a more philosophical possibility, one that many physicists hesitate to state openly, that the question itself may not be fully well defined. When we say before the Big Bang, we are borrowing intuition from everyday life, where events happen in sequence. One moment leads to another. Causes precede effects, but at the origin of space-time, that framework may dissolve entirely. If time emerges with the Big Bang, then there is no external timeline against which earlier states can be measured. There is no larger clock ticking outside the universe, only the universe itself. And yet, even this does not fully satisfy the human mind, because we are pattern-seeking beings. We are built to look for origins, for mechanisms, for something that explains why things are the way they are. So we keep pushing deeper. We imagine pre-existing fields, higher dimensions, quantum vacuums, cyclic rebounds, and multiversal landscapes. Each theory is an attempt to preserve continuity, to ensure that reality is not arbitrary, but connected through some deeper logic. But there is a tension at the heart of all these ideas. The further back we go, the less the universe resembles anything we can intuitively understand. At some point, even geometry may not apply, even space may be a derived concept, even existence may need a different language, and yet something undeniable remains. The universe we observe today is structured, ordered and governed by laws that are astonishingly consistent. That consistency demands explanation. It suggests that whatever came before, if before exists at all, was not random chaos, but something capable of producing structure, something that allowed the emergence of space, time, and matter in a stable, coherent form. And so the mystery deepens, because now we are no longer just asking what preceded the Big Bang. We are asking what kind of reality can give rise to a universe that can ask the question in the first place. And that may be the most profound clue of all. There is a final possibility, one that does not offer comfort, certainty, or even a clear narrative. Only perspective. What if the Big Bang is not an event inside a larger reality, but the boundary of all possible description? In this view, the universe is not something that happened in time. Instead, time is something that emerges from the internal structure of the universe itself, like an effect generated by deeper relationships between quantum states. And if that is true, then asking what came before the Big Bang is not like asking what existed in an earlier chapter. It is like asking what lies north of the North Pole of reality. The closer we approach that boundary, the more our language begins to fail, not because we lack imagination, but because we are using concepts designed for a world where time flows and causes precede effects. At the Planck scale, those assumptions break down. Space becomes uncertain, time becomes probabilistic, causality stops behaving like a rigid chain and starts behaving like a statistical pattern. In that regime, the universe may not have a single origin point at all. Instead, it may be defined by a self-consistent structure, one that does not require a beginning, only internal coherence. And yet, even in this abstract view, the question does not disappear, it transforms. Because whether the universe began from a quantum fluctuation, a cyclic bounce, a collision in higher dimensions, or a timeless geometric state, one fact remains unchanged. Everything we know emerges from something we do not yet understand. We stand at a very specific moment in cosmic history, a universe already 13.8 billion years old, filled with galaxies, black holes, dark matter, and the faint echo of its earliest light. But we are not outside of it. We are inside it, trying to reconstruct its earliest conditions using information that has already been stretched, diluted, and transformed by time itself. And that means every answer we find is, in a sense, a reflection, a shadow of the original state. So perhaps the real story is not about what came before the Big Bang. Perhaps it is about what we are doing now, because every telescope pointed into deep space is also a form of time travel. Every measurement of cosmic radiation is an attempt to reconstruct a moment we can never directly access. Every equation is a bridge built toward a horizon we may never fully cross. And yet we keep building, we keep looking, because the universe leaves us with a paradox. The more we understand it, the more mysterious its origin becomes. And somewhere in that tension, between knowledge and the unknown, the question continues to echo, not as a problem to be solved, but as a signal from the edge of what we can know. What came before the Big Bang? Maybe the answer is not something we will ever fully reach, but something we will always move toward.